Today, we're going to talk about something that's jumping right out of the movies and into the real world. I'm talking about the new age of general-purpose robots. You know them, right? The brilliant, sometimes kind of clumsy, sometimes downright terrifying robots from our favorite sci-fi flicks. For decades, that's all they were, just ideas. But now, thanks to some incredible advances in hardware and, even more importantly, in software, they are becoming very, very real. All right, so here's our game plan. We'll start with the huge problem that's always been a roadblock for robotics, something called the robot paradox. Then we'll get into the software leap that's finally solving it. We're going to look at just how close they are to us, cover the physical hurdles that are still there, and wrap up by looking at what this all means for the future of work. So let's dive right into that core challenge. For all their insane processing power, why is it that robots have such a hard time with tasks that a toddler can do without even thinking? Well, it all comes down to this fascinating idea called Moravec's paradox. It basically points out this super weird contradiction. A computer can solve insanely complex math problems in a blink, but that same machine might struggle to just pick up a pen. For machines, the hard stuff is easy, and the simple stuff is incredibly hard. To really get this, just think about picking a single blueberry. You don't consciously calculate the exact pressure from your fingers or the perfect angle of your wrists. You just do it. But for a robot, traditionally, every single one of those tiny little micro movements had to be programmed for every possible shape or softness or position of that blueberry. It's a computational nightmare. Okay, so if that's the paradox that's held us back for so long, what's the big solution that's changing everything? Well, the answer isn't in the gears and motors, it's in a total revolution in software. The big breakthrough is something called embodied AI. Now, instead of trying to program every little thing, embodied AI gives robots the power to see the world through sensors, to understand what they're seeing, and to adapt their actions on the fly. They're not just executing commands anymore, they're actually learning. So how does this magic work? It's really a combination of a few key things. You've got behavioral cloning, where robots literally learn by watching videos of people doing stuff. Then there are reasoning models that let them take a big command, like tidy up the room, and break it down into smaller, logical steps. And all of this is built on top of these incredibly powerful foundation models. The same kind of tech behind things like ChatGPT, but trained to understand the physical world, not just language. Now, don't let this diagram overwhelm you. The key thing to see here is the flow. You've got all the inputs from the environment coming in on the left, running through all these layers of perception and planning in the middle, and leading to a physical action on the right. This, right here, is basically the brain of a modern robot. Okay, so we've established the software is getting ridiculously smart, but the billion-dollar question is, how do these new robots actually stack up against us, in the real world? This chart gives us a really fascinating, data-driven answer. It's basically a report card comparing robot abilities to what we'd call human-like capability across a bunch of different skills. Let's dig into what it's telling us. In some areas, it's pretty mind-blowing. Robots are already at or even past human-level performance. Take a look at vision and speech recognition. Those foundation models have pushed them beyond what we can do. And even for physical things, like grabbing a solid, rigid object, they are getting very, very close to our own ability. But hold on, it's not a complete robot takeover just yet. The data also shows where we humans still have a pretty big lead. Think about something delicate, like handling a soft piece of fruit, or understanding the subtle meaning of a human gesture. In these more intuitive, less predictable tasks, robots still have a long, long way to go. So while the software side of things is moving at lightning speed, that's really only half the story. A robot's brain might be getting smarter, but it's still stuck inside a body. And the hardware itself comes with a whole new set of problems. Yeah, even the smartest AI is kind of useless if the hardware can't pull its weight. The biggest problem? Power. Most humanoid robots only have a battery life of 3 to 5 hours, and then they take forever to charge. Dexterity is another massive one. Building a robotic hand that can do everything our hands can do is just incredibly tough. And on top of all that, engineers are in this constant battle to make things smaller, better, and cheaper all at the same time. All right, let's put all the pieces together. With the software getting better and the hardware slowly catching up, what does this actually mean for that next big frontier of automation? The workplace. This table really sums up the gigantic shift we're talking about. On the left, you've got your traditional factory robot. It's strong, it's fast, and honestly, it's pretty dumb. It does one single thing perfectly, over and over, inside a safety cage. But on the right, you have the general-purpose robot. It can do tons of different things, it learns as it goes, and it can work right alongside people in messy, unpredictable places. So, what does that look like day to day? Well, imagine a warehouse. The old robot would just stop and flash an error light if a box was in the wrong spot. The new general purpose robot, it'll just see the box, figure out how to move it, or maybe just go around it, and then just keep on working. That adaptability, that is the real game changer. And really, this brings us to the most important takeaway. When you combine this powerful new software with hardware that's constantly improving, you realize general purpose robots aren't a fantasy anymore. They're coming. So the question we all have to ask ourselves now is not if this is going to change things, but just how fast is it all going to happen?